So in 4.5, we are going to be working with two special kinds of triangles. And we are on paper because there's a lot of algebra and arithmetic today. So it's a pretty easy lesson. But it's like solving a puzzle. So we're going to be, I have to give you the tools to solve it. So you're going to have your notes out when you're doing your homework. And if you ask me or Miss L for help, we're going to say, look right here in your notes. We're not going to say just set those two things equal or those add up to 180. So make sure you write it down. And first one we have here is that an isosceles triangle has two congruent sides. So right here and right here, I want you to mark these nice and dark. If you see those dashes, you're 100% sure that they're equal. And if they're equal, then it's an isosceles. But the other thing that happens is draw an arrow across like this. These guys over here, which are called the base angles, are also equal. So you're going to be kind of working a puzzle today. Like if you look up at my whiteboard, go ahead, everybody look up at that picture. You're going to see, this is how your brain kind of has to work through your worksheet. It's like a puzzle. Some people finished it really fast. They're like, okay, this is isosceles with the markings, right? And then they'd say, well, then this is 48, this is 48, and then I can get W, and you just kind of have to work it like a big puzzle. So I had one girl done in like 10 minutes. She was just like, okay, that's what I'm doing, and they were all right. So she was my person helping everybody else last hour. It will help if you have your notes open. So what we just said is that if the two sides are the same, you get to get those two. And if on your worksheet you get those two, watch this. Go ahead and put a triangle right here. And suppose we go like this, and I put a 40 right here. You can get all three of them now. Because which other one's 40? The one at the top or the one at the bottom? The bottom, the base angles. How are you going to get your top on your puzzle piece today if you had to? What? Yep. Yeah, you're going to use an old one from last chapter that the angles in a triangle add up to 180. All right, so there's going to be a lot of adding stuff up, subtracting from 180, setting algebra pieces equal. We're going to prove that because we're now at a point where you guys can actually understand where some of these theorems come from. We're getting really good at proofs. So just one proof today, and there aren't any on your worksheet. They're more algebraic numbers. But it says we're going to prove why those angles are the same. Why, when somebody started writing a geometry book, could they come up with this theorem that if the sides are the same and it's isosceles, the angles are for sure? What that person did, historically, I have no clue who it would have been. Somebody, usually they're from Greece, a very long time ago. They said, well, I'm going to bisect this angle up here. And we know what that word means, correct? What does a bisect mean? Yeah, split it in half equally is what they said, those of you watching the notes. So if I drew a bisector, I could go like that, right? Also, I see a shared side, so I could see this. Whoever historically came up with this theorem said, oh, these triangles are the same by side angle side. And just like you guys in your groups yesterday, you could say, okay, well, if the triangles are the same, then their corresponding parts are the same. So if it is isosceles, then those base angles are the same because they're actually corresponding parts of congruent triangles, which are congruent. So that was kind of like what we did yesterday where I said write a plan. Now we can get our proof really quickly. I always say that I'm going to go like this, but you can't. You can today. How I say I'm going to be lazy and just draw an arrow to that given. Never do that on a test or quiz. But we've been doing, proofs is really not the focus of today's lesson, so I'm going to be abbreviating quite a bit. But go ahead and draw an arrow there. Just write S, T, and R for your reasons. As always, we had some given, right? Our given was a free pair of sides and the word bisect. So we're going to take the fact that we know what the word bisect means, and we're going to make a statement. Because they're numbered up there, right here, I'm going to take advantage of that and say angle 1 is congruent to angle 2. Look at all you good little monkeys. All right, angle 1 is congruent to angle 2. I'm going to give a reason. It wasn't because they told me. It didn't say up here angle 1 congruent to angle 2. It didn't have the arcs in here at 1 and 2, but it gave me a word. So I'm going to put excellent. If you could, those of you watching the video, somebody said definition of bisect. Thank you, Kaden. Because I knew what the word meant, right? So excellent. So that gave me another angle. So when I was doing my plan, I was like, okay, it's isosceles, so the sides are the same for sure. Well, I've got a bisector, so for sure these guys are the same. And if you remember, we put a double dash on here for our other side. And we've had that one so many times. That's the one I cry alligator tears if you couldn't tell me why XB is congruent to itself. Royce, don't make me cry alligator tears. Why is XB congruent to itself? Thank you. I'm not going to cry. If he said, oh, I don't know, I'd be like, no! Oops, I'm on video. Sorry. Sorry, I forgot I was recording. All right, whatever. Sorry, guys. That was probably really loud. And somebody asked me to record today. I'm like, I do need to because I haven't taught this lesson before. All right. So where was I? I was being weird. And so I was given the pair of sides. And then I used definition of bisect, and Kaden told me I got some equal angles. And then Royce was good with getting me the reflexive, so I'm good to go there. So my next statement I'm going to make is I'm going to stop and say I've got a little side angle side action going for getting the triangles congruent. I have to extend my page. When I do that, I often lose the stem of the problem, so I have to call on one of you guys. Lily, can you tell me what triangle is congruent to what triangle? Because I can't see it anymore. Did she list them in the correct order? Yeah. Yes? Thank you, Lily. All right. That wasn't the point, though. The point was to prove this theorem that says if the sides are the same, like up here in the picture, I can have the base angles the same. But those are now corresponding parts on congruent triangles, which are congruent. So right here, can you tell me, Jaden, can you unplug your ear pod, please? But can you tell me, Noel, what was the proof? I lost the problem. It said to prove angle.
Oh, Y is congruent to.
Thank you, kiddo. Z?
Yeah.
Awesome. So this is a proof of why every time on your worksheet today, Emma sees this picture, she's going to go, oh, these are the same. That's why. Okay? So we're only going to prove it once. Up on the board right here, the minute you see isosceles, you're going to go 48, 48. Okay? If you ask me for help, I'm going to point to this and say, what did we prove? That the base angles are the same. So you're going to get those, steal those angles. And here's the converse of that. Remember, converse means you switch. So we just said if the sides are the same, the base angles are the same. This one says if the base angles are the same, you get to go steal the sides or set the sides equal. So right now, we're just going to work with that in a couple different situations. This top part should be easy. Okay, so you're either going to have the base angles marked the same, and you're going to go, oh, well, that means these sides across from them, go ahead and draw the arrows, have to be the same. So you're just going to go x plus 4. You have to equal 11. Easy peasy. Subtract the 4. You're going to go x. You have to be 7. If the base angles are the same, then the sides across from them are the same. They have to be marked. You can't just assume it, but this is good. You're going to go, oh, that's isosceles. Means the legs are the same. You go ahead and do number 11. It's easy. What's the answer? 2. All right, so those of you watching the video where they're setting 6x equal to 12 because we spot those base angles the same, we divide by 6. Number 12, you shouldn't even do any work. You should look at that and go, oh, the base angles are the same, so it's isosceles. What's x? Done. Okay, they said 13. Those of you watching the video. Let's go, since we're getting it. Let's go do number 13. Oh, I see the base angles the same. I can set the sides across from them this equal to each other. I always draw those little arrows. When we're helping you with your homework, I might say, what is it? What do you should draw those arrows across, set those guys equal to each other. So I'm hoping you're a little bit ahead of me, and I'll just kind of catch up to you here. I'm going to subtract the 5. We're going to have a nice 7x equal to a 14, just doing some pre-algebra. There's a lot of numerical stuff. That's why we're not typing today. It'd be a pain to. The words I love to type, but this is not fun to type. This is just nice. I like this lesson. It's just nice, easy math. Don't you agree? Nice and easy. All right. There are some that are tricky on your worksheet, though. We're getting there. Right now, we're just doing. All right. I recognize isosceles, not because they look the same, because they're marked. That means that the angles are the same. So I'm going to go and set 5x plus 7 equal to 52. Go ahead and solve that for me. How about Dylan? Go ahead and solve this for me, bud. I haven't called on you for a long time. Dylan?
Yeah.
What will I do first?
Okay, you just set an equal, so
Yep.
then what you do is you subtract 7.
Thank you. Is subtracting 7 getting to 5x equals 45. And then, Dylan, what would you do? Divide by 5. Perfect. 45 divided by 5 on Fridays is 9. All right? Easy. Now, what if on your puzzly sheet, there's a y right here? I'm going to challenge you to go find y right now. Because on your worksheet, I'm starting to up the difficulty here. There's going to be more variables in different spots. You go see if you've got a way to find out y. Keep in mind, you know both of these are 52 because it's isosceles. Okay? I'm just going to give you some time for you guys to go find it, and then I'll call on somebody. If they say, I don't know, then I do more of them. So you guys control how much homework time you have. I'm actually not going to pick on somebody raising their hand. All right. So I really want you to think about how am I going to get that missing angle up at the corner. Andrew.
Both of the angles that you have minus 180.
Yeah, he's saying, well, I have a 52 and I have a 52. So I'm assuming he meant to say add the 2 I have, right? So he's saying, okay, I've got 104 taken up in there. By the way, we know they're equal because we had those dashes on there. And then he said subtract it from what? 180. So he would do 180 minus the 2 that he already knows. He'd get a 76. It's a little bit of a puzzly piece. Be very, 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 very careful in number 15. Because now you're going to go, oh, every problem, I've got a low battery. Just a second. I want you to go put something in the missing angle up there. Go put something in the missing angle. You do not set those two things equal to each other. So you really have to approach every problem by kind of looking at the information that was given to you. So what's that missing angle up there in the top right corner? What are you going to put in there? 3x, exactly, you guys. Because it's isosceles, not because it looks like it, because of the red dashes. So I head across from those red dashes, and I say, oh, those angles are the same. So this one is the same as this one, and it's 3x. Now, I've got to use something from last chapter to figure out what x is, Mallory. Do you know what I'm going to do with these angles? I can't say 3x equals 3x because that doesn't help me get x. Do you know? Go ahead. Yeah, now in a triangle, in last chapter we said the angles in a triangle always have a sum of 180. So now this one's got a little different algebra, right? You don't have to supply reasons for what you do today. You're just going to do straightforward, easy algebra. So, but what is the reason for when I call this a 10x? Do you remember? Combining like terms, excellent. All right, and that'll equal 180. And then I get x equaling, divide by 10, a nice 18. And this one did say to just solve for x. All right, next page. Cruising right along. Now, this one I want you to star, because this is the one like I always tell you, you guys have the advantage of being my second class. there's a lot of information in this one that they were missing last hour. So this is the one that's going to get you unstuck on your worksheet with some of them. It says this: if a line bisects the vertex of an angle. I put one up on the board right here. Look at this guy. Everyone looking? Thank you. This is showing that this line is bisecting that vertex angle. This guy is called, let's point at it, the vertex angle. I know it's being bisected because I see those single arcs up there, which means it's telling me it got cut in half. There are two things you get to conclude from that. One is that the line is perpendicular. What does that mean? Right angle. So I'm going to tell, if you ask me for help on one like this, I'm going to point you to this and I'm going to say, look at that word. What does that mean? And Zach's going to go, oh, I know I have 90-degree angles in here. I'm going to say, well, write that down. Okay. We good with that? Then let's go back up here and say what else it says. It says it's a bisector of the bottom or the base. What does bisect mean? Split in half. So you're going to go, oh, all right. Boom. Now you can look up at the board. You can use everything we know to get all the missing pieces. Watch. Here we go. If this is 48, right? What's this one over here? 48. How could you get W? 180 minus 48, correct? What's this one? And 48. Could I get this one?
Yeah.
Yeah. Actually, I should have put like a Q up here or something. What do these three have to add up to? 180, right? What's Y? 5. Okay, so you see how you're going to be solving puzzles? It's kind of fun. I like this worksheet today. It's like it's a puzzle, and I like puzzles. So let's go down here. This is an easy puzzle, but it's isosceles. Awesome, right? And the base angle is 54. I want you to go add other stuff to that picture before we find X, okay? X is not 54. This guy is 54. If you're stuck, I'm going to say, look at these and look at above what it said. And you're going to go know another angle, correct? It said that if the vertex angle is bisected, oh, it is, then it hits at what kind of an angle? 90 degrees, and it cuts this into two equal pieces. How is that? Somebody who hasn't spoke yet today. How is that going to help me get X? How about Libby? Do you know how, knowing that this is 54 because I've got my base angles, and this is 90 because we just said it's a perpendicular bisector, how's that going to help me get X? Yeah, she's going to go, well, I'm in a triangle now. So I'm going to tell you, if you are missing parts, you will easily find them today if you use your theorems. Okay? Miss Ellen and I aren't going to say, just set those equal. We're going to say, go look at what it says when this is bisecting. Oh, 90 degrees. And then we're going to say, what do these add up to? So we're not going to just tell you what to do. All right, would you know how to solve that? I think you would. So I'm not going to. I'm going to save us some time. I want everyone to finish their worksheet in class today. So now we have another kind of triangle. It's an equilateral triangle. And I don't care if you know what the word corollary means, but you do need to know that if all of the sides are the same, lateral means side, like if any of you guys play basketball, moving laterally is like this. Vertically is jumping up and down. Equilateral triangles have all sides the same. When that happens, though, all the angles are the same. So let's go over here, and I'm going to add to this right here. Not only are they the same, we know what they all are. I want you to kind of digest what I just said. Not only are these all the same, I can put numbers in for all of them. Raise your hand if you, Jake, go ahead.
60.
Why? Yeah, he's going, okay, there's 180 degrees in there. She just told me that all three angles are the same, right? So I want you to go up on here and not only have those arcs, but we know all those arcs are 60. So if on your worksheet today you just see this, go ahead and look up here. You see All right, same, same, same. You're not just going to mark those the same. You're going to go 60, 60, 60. Does that make sense? All right. So let's go down here. And it says the measure of two sides of an equilateral triangle are 3x plus 15 and 7x minus 5. By the way, the sides don't add up to 180. I've seen this. Miss Al, have you seen this before too, where kids will go this plus this plus this? The sides don't add up to 180. The angles do, right? The sides are equal to each other. So we're going to say 3x plus 15 equals 7x minus 5. It's the only way I can get started. All the sides are the same. I'm looking for the measure of this third side. You guys go solve that for me. And put your pencil down when you're done solving it. If you're watching the video, just go get me an X, and then we'll go kind of solve this puzzle as well. I actually didn't notice this last hour, but there's some false information up here, Miss L. Miss L. Right? Because what are you guys getting for your X?
20.
But, well, 5, right? You're going to get a 4x equals 20. So my X is going to equal 5. Agreed?
Yeah.
Okay. So I'm going to go get my sides. Let's go see if they match. They better, otherwise you didn't solve it right. Whoever told me it was a 5, right? This would be 35 minus 5. This is 30. Let's go put that on there. This is 15 now, plus 15. That's also 30. So what's my missing side? Anyone see why I just paused it? I was solving it in my head, and I'm like, there's some bad information on this picture. What happens if you put that 5 up here? What do you get? 20. But what did we just say? Equilateral, it should always be what? 60. So I'm going to go like that because that's bothering me. I have OCD.
Oh, you know what we could do?
So we could tweak it and make it work, but at the point I was just looking at it going, what? That's not right. I don't know where that came, what picture that was screenshot off of or whatever, but we got to take that off of there because it bothers me. Does it bother you guys? Or are you fine? It shouldn't be 20. What should it be up there? 60, right? Yep.
We could go to the 18 and draw 10 out.
Yeah. All right. So are there any more at the bottom of this? I think so, right?
Yeah.
These are the puzzly kind. This is what your worksheet is like now. All right? So now if you're like, this was easy, it kind of was. But when they get more complicated, so we just have to sort this out. I want you guys, instead of me talking you through it, use what we just said about isosceles and equilateral. You're going to decide which one this is based on its markings. You're going to go look at what it says about this one, whether it's isosceles or equilateral. It's going to allow you to find X. Once you have X, you'll be able to get the Y. I want you to try it. You're solving a puzzle. You're going, oh, all right, same, same, same. Equilateral or isosceles? Because that's what Miss L and I are going to ask you if you say, I don't get this one. And we're going to say, what kind of triangle is this? And what are you guys going to say? Equilateral. And we're going to say, what's true about the angles of an equilateral triangle? Go look at your notes. Not only are they the same, they're what? They equal 60. Thank you. So you're going to go 4x equals 60.
Oh, I have Y.
Okay? Excellent. I'll get right to you. So if you divide 60 by 4, you get a 15, correct? So we now know 15 is x, but we also know because it's equilateral, whatever girl in the back said 60. Now what's y?
120.
And y, like W-H-Y. Y is y, 120.
Because 60 plus 60 is
Yeah, we know that we have, well, so there's a couple ways to do it. He's using the exterior angle theorem from last chapter, that this is equal to 60 plus 60. That's great. Yeah, you just said 60 plus 60. But also, these make a line together, which is 180 degrees. So either way, that's 120. This is about as hard as they get over here. Because do you see a single number on there? No, but yet you can actually get every single angle. So I just want to give you guys a chance to troubleshoot it. I don't see a number, but I do. I see one with a symbol, but just be quiet. Go put a number in at least one of those angles. Okay? And that's what, if I have to help you today, I'm going to say, what is this? Right? Now I see two triangles. They're both what kind? Isosceles or equilateral? Isosceles. So I'm going to go look in how I can get missing angles, because that's where my letters are on isosceles, and that should get you going. Okay, so I'm just going to give you a little time to work it out, and then we're done. All right, so I said go put a number on there. Everyone should have found that one, right? What number? 90. Yep, you're going to go like that. Then the minute you see these sides are the same, you should go like this on your picture. What does that trigger? Who was able to continue from the 90? Nope. What do I know?
90.
They have to be 90. All right. So if this is 90, right? These two are the same. How much is left in this bottom triangle if this is taking up 90 degrees? And don't these two have to share it equally because base angles are the same? You're nodding, right? Did anyone spot that? So what do I need to do with the 90 degrees left for these two to share? Yep, Lips? Divided by 2. So I'm going to go 90 divided by 2 is 45. And that's going to get me n. So I'm going to go 45. I'm going to go over here. And I'm going to go 45. And then if you say I'm stuck, this is what I'm going to do. Okay? I'm not going to be very helpful today. I'm going to say if you know this is 45, you know another one's 45.
Oh.
And yes, then that's what it's going to trigger. And Avery's going to say, well, if this one's 45, where else is 45?
I know.
This one, because of the single arc. Okay? And then if she goes, well, I'm still stuck, I'm going to go, well, this is isosceles. Go like this. Same as this. Libby just said on the last one, right, to take 180, remove the 45. So go to your calculators and do that for me because I can tell it's going to be a decimal. Okay? So we've got these three. This guy. I'm going to grab my highlighter while you're doing it. You guys are really listening today. I'm going to grab my highlighter here. And we've got the 45. We knew it was 45 because of that single arc. We know this one and this one are the same. What do the three yellow angles have to add up to? 180. So what are you going to do on your calculator? So take out a calculator, some of you. What are you going to do?
Divide 45 by 180.
Not 45, but I'm going to take 180. Yeah, I'm going to subtract the 45. Somebody on their calculator, go do that for me. Because I'm saying, well, these three yellow ones add up to 180. So let's get there's 135 in there. That's not the answer. There's 135 for those base angles to share equally. What do you get? 67.5. Okay? So they're very puzzly. I think they're fun. Because I'm sick of doing proofs. So I think, well, I'm going to stop recording. And I'll tell you. The assignment, guys, if you're listening, is worksheet 4.5. And we aren't skipping any of them, but you are my second